Thank you very much for coming. Good afternoon. I hope that you've had a good first day or first half of the day, first morning here in Chicago at Ignite. Thank you very much. My name is Mark Mortimer. My co-presenter, Guru Venkataraman, and I are going to be talking to you today about integration and extending our mission-critical solutions into the cloud. I'm the product manager and marketing lead for Microsoft's integration technologies and API management. So the technologies that I'm responsible for, most of you, I would say, are familiar with, include BizTalk Server, Azure BizTalk Services, App Service, API apps, and Logic apps, and API management. So those are the technologies that I focus on. And Guru, in his role as a senior program manager on the integration team, is driving our work around BizTalk Server as well as the BizTalk Services work that now exists in Azure, App Service, API apps, and Logic apps. So just as a quick checkpoint for folks in the audience, how many of you are currently leveraging on-premises integration solutions leveraging BizTalk Server? Yeah? Okay, great. And how many of you have started exploring or are familiar with App Service, Logic apps, or API apps? Of our new announcement, okay? In this session, we'll be primarily focusing on App Service, Logic apps, and API apps. But this is building on the foundations that we have from our solutions over the last 15 years, and so many of you have backgrounds in this area. We'll leave time open at the end for Q&A to allow you to ask questions and bring up any kinds of open issues that we may not have had time to cover in adequate detail during the presentation, and we'll be happy to take your conversation and discussions after the session. We're going to start off by focusing first on the App Service framework, talking about the various components that make up App Service, including web apps, mobile apps, API apps, and Logic apps. And we'll talk about how each of those collections of capabilities helps you to take your integration solutions to the cloud. And we'll also talk about what cloud means in that context. We'll also talk about how hybrid connectivity allows you to, in this new paradigm, develop where you want on-premises or in the cloud, test where you want on-premises in the cloud, and deploy applications where you want on-premises in the cloud to access data that resides where it needs to reside, whether that's on-premises or in the cloud, and access any class of devices. So whether those are headless services, whether those are mobile devices, whether those are browsers, really the choice is yours. So what I just said in that last 30 or 45 seconds is actually a pretty huge deal. What it means is that this suite of integration technologies lets you access applications and data wherever they reside with applications that you're creating or solutions that you're creating that can also be developed, tested, or run in deployment where you need to have them run in deployment. Tested where you need them tested, and developed where you want them developed. So, and with this capability of bringing together endpoints and delivering them to any end interface, whether it's a mobile or a browser or a headless application, is a tremendous flexibility for businesses to be able to drive. And in addition, we've worked on interfaces inside the portal that streamline the development and production of these solutions in a way that's more consumable than ever before. So Guru will be showing that as he gets into his demonstrations. So if you've started with BizTalk Server, You know that BizTalk Server was released in initial versions in the late 90s. We had an enterprise class product that was very disruptive to the industry in terms of price, performance, and capabilities. In the 2006 release, so now almost 10 years ago, that was really the first release that was more deployable, more exposed to development, and really began seeing a huge uptake in enterprises around the world leveraging BizTalk Server as a foundation for building integration solutions. Since then, we've released 2009, 2010, 2013, and in July of last year, we released 2013 R2. We have a next release of BizTalk Server coming out in the 2016 timeframe, and as you heard in the keynotes this morning, SQL Server 2016 and Windows Server 2016 are delivering a platform of advanced capabilities that really springboard what we're doing in the next releases of both BizTalk Server and also App Service. Some of you also know and have worked with BizTalk Services version 1.0 on Azure. We released BizTalk Services on Azure in November of 2013. So now around a year and a half ago, we released that capability and made it generally available. And Guru and I and our partners and our MVPs are engaged every single day with our customers around the world who are building mission-critical applications on our platform. And what you told us is the innovations that Microsoft is developing in BizTalk Services version 1.0 are powerful, but we aren't going to be able to consume them unless you make them available for us both in the public cloud as well as in the private cloud. And so Scott Guthrie and Bill Staples and the engineering teams inside of Microsoft made a hard shift about a year ago to see how all of the investments we had built in BizTalk Services could be refactored over a new platform capability. And what they found was that those investments, in fact, could be refactored. And so in December, at Integrate 2014, we announced that we were going to not come out with a private preview of BizTalk Services v2, but that we were going to move straight to a public preview of a new set of v2 services that were going to deliver all of the advances that we had promised, plus portability between private and public cloud scenarios. And so at Integrate 2014, Guru and his team in December actually demonstrated how these refactored services actually enabled portability between Azure Public Cloud and private cloud, at this time running on Windows Server 2012 R2 and the Azure PAC. But with Windows Server 16, as you heard in the keynote today, and as you've been hearing since around November of last year, our investments in this fabric are quite substantial and enable very high performance scenarios as well as scalability and throughput that really meets mission critical requirements. And so the new advances coming out in the next version of Windows Server are a really important enabler of a lot of the capabilities. So what we'll be focused on during the presentation today is really how the new app service capabilities extend our capabilities, extend the ability for you to develop powerful integration solutions. Today, in preview on Azure in App Service. We're going to be moving into general availability of App Service in the July-ish timeframe, so summer is what we're saying, summer of 2016. In this release, we'll go from preview into general availability. And so what we'll be talking about is what we currently have available in preview today to enable you to take your integration solutions to the next level and to enable you to really address hybrid integration. So the app services in Azure today, or really yesterday, were Azure Web Sites, Mobile Services, and BizTalk Services. But as I mentioned before, You told us loud and clear that our implementation of BizTalk services needed to be more open and more capable, enabling scenarios that not only addressed advanced integration requirements, but they also needed to be portable between public cloud and private cloud. You also told us, and not only you, those folks in this room, but a lot of our mobile and web app developers told us, I want access to advanced integration capabilities, but you got to make them easier for me to consume. You got to make them easier for me to put into my apps and take my apps to the next level. And so what we worked on was not only all of this great code portability and refactoring of components and extensions of new capabilities, but we also worked on making these interfaces more consumable to a much broader range of developer audiences. And the way we did that was through App Service, which is one integrated offering that brings together all the goodness that we've created related to web apps that scale to meet business requirements, that are supported in a content delivery network, that extend reach for the investments that you're making. And these web apps actually then enable you to create both headless solutions as services that can be exposed as APIs, as well as browser-based capabilities that can be delivered to any client, and mobile apps which extend that reach to any mobile device, whether it's a Windows or iOS or Android operating systems for mobile devices, built over the top of two very powerful enabling components, and I'll refer to them from the bottom corner up. So API apps, in shorthand, really are how you as a developer define an endpoint connection. So as you, for example, could say, well, in my API app, what I'm going to do is I'm going to connect to an endpoint. That endpoint could be an external application like Salesforce.com or CRM Online. It could be an internal application like a SQL Server database or Oracle instance on premises. It could be an instance of data that exists in the cloud. It could be a SAP application existing either in Azure or running on premises inside your data center. So these API apps really define how do I access this endpoint, how do I authenticate to this endpoint, what kinds of information do I pull from this endpoint, and how do I need to use rules or transformations to manipulate the data coming from that endpoint. And so really, that integration capability is supported by those API apps. And then, as I mentioned before, there are web apps that enable that connectivity, mobile apps that extend the reach, API apps that define that connectivity, and logic apps that really let you bring together these capabilities into a series of activities. So you can think about this as a way of linearizing your application at the very simple level. It can also enable workflow or business process capabilities for more advanced scenarios. And this workflow engine, and Guru is going to go more into depth on the details of this, are very open in terms of the code that actually gets generated. So you as a developer have a visual design interface to work with, and out of that interface, it actually generates the JSON-based workflow definition, which gives you that total control, scalability, and flexibility. So App Service is really the confluence of web apps, logic apps, mobile apps, and API apps. And so with this introduction, we'll pause for just a quick second. If there's any questions from the audience, we'd love to hear from you. Anything that you have that we need to focus our attentions on. And then I'm going to turn over the rest of the presentation to Guru who's going to actually talk you through how all of these powerful capabilities come together and demonstrate to you how these building blocks can actually help you create solutions on top of Azure in the preview of App Service. Thanks, Guru.
Cool. Thank you, Mark. Good day, everybody. Nice to see most of the familiar faces around. So as Mark was explaining, App Service is a whole new model of an architectural pattern, so to say. For most of you who come from the BizTalk server background, this might sound kind of familiar, but still there are lots of new things that we need to think at it as an application platform rather than just an integration platform. So the way that we are seeing it inside Microsoft, BizTalk server and that platform kind of provided a whole lot of foundational technologies that are relevant to a much larger audience, larger developer audience, which are not confined only to that integration space. The scenario that we will be talking about today is a very simple scenario, which is that as developers that we have seen almost on an everyday basis, there is data residing in some data source, like let's say SQL source or Oracle source that is already inside your enterprise. You just want to provide access to the data from an ASP.NET application or a mobile application. A very, very common scenario. What's that got to do with integration? I'm not pulling in multiple data sources and stitching them together here. I'm just connecting to one data source and showing it in one application. What has integration got to do with that? So if you were to think about it as a development platform, just to achieve that much, there are a couple of things that are involved in there. That data is in some record set format, and if you have to display it on an iOS table, you need to do some data normalization. You need to do some entity mapping. You need to do some authentication and authorization. So all of these things has got nothing to do with that simple developer's requirement of being able to just read the data and show it here. So if you were to wear the cap of your integration architect here, you would say, hey, all I need to do is just provide a SQL connector and read the data as XML, and I can plug it in wherever I want. So it's no more an XML data, SQL data, it is no more an Oracle data, it is simple XML or a JSON data that I can plug it anywhere. This is something that is very common to most of us in the integration world. But when you get into the developer's world, like a .NET developer or a Java developer, this becomes a very complicated problem. And it's a very common problem that people run into on an everyday basis. So now, how do we take this technology that we already have available for these integration guys and make it available to the larger audience? That's the premise of app services. So people may be wondering, why are we taking web services, logic apps, mobile apps, and plugging them all together as one service? So the idea behind this app services as a platform is we have to reach to a much larger developer audience, and their common problems are simple transformations, simple connectivity. When I say simple, simplicity of connectivity. It could be connecting to SAP or Oracle or SQL in the backend, but the simplicity of connectivity. I don't have to know SAP, I don't have to know Oracle, I don't have to know how do I manage SQL connections, but I just want to access the data. So that simplicity part. And be able to transform the data. Like if I'm taking a field from SAP, a field from Oracle, a field from Salesforce, and I just want to show it in my iPad application. So as an iPhone developer or as an iOS developer or an Android developer, I don't have to worry about how do I do this mapping. Can I use that simple graphical UI that BizTalk had, where I was just dragging and dropping fields and it was mapping out to a beautiful form I wanted? Can I get that kind of a functionality? Can I get some simple encoding functionalities that BizTalk server used to have, right? So like encoding capabilities like, can I move fast on this? Okay. So some simple encoding functionalities, like I have some XML data, can I convert it into JSON? Can I have some flat file data, can I convert it into XML? Some simple encoding functionalities. And how do I do some business rule functionalities? Like I have a simple rule which says give a 10% discount to my premier customers during Christmas season. It's an English-like statement. Can I use that kind of a powerful rule engine in the context of my mobile application development or my web application development? So these technologies are not new. These technologies are at least a decade old. BizTalk server has always had these technologies. How do we make these technologies available to a larger developer audience? So now, you may be wondering, why is this relevant to today's talk about hybrid computing? Given the fact that most of you come from the integration background, server background, you might find it relatively simpler to say, hey, if I had to connect to a hybrid world, that is part of my data is on-prem and part of my solution on the cloud, I just put a BizTalk server there and expose it as a WCF proxy, and voila, I am done. The technology that we are talking about today is very similar to that in terms of usage, but the fact that you needed a BizTalk server to do that makes it a very heavyweight application. All that I wanted to do was connect to an on-prem database. That's all I needed to do. But today's implementation says that you need to have a full-blown server product sitting there just to provide that connectivity. How do I obfuscate that need? How do I make it lightweight and simple for anybody to use? So that's the idea behind app services and in the context of hybrid. I don't know how many of you had a chance to try out a preview of hybrid connectivity that we introduced last year as part of BizTalk services. It was in preview for almost 7-8 months, and now we have introduced it as part of app services. So the goal there is we will have a relay endpoint sitting out there on the cloud. Most of you are familiar with Service Bus, I believe. So there is a Service Bus based relay endpoint sitting out there on the cloud. And that relay endpoint just sits there as a listener. So when an external client is trying to access your SQL server, the external client just sees the web endpoint. It doesn't know that there is SQL server or Oracle server behind the scene. So this cloud endpoint is always available, and it is highly reliable and those kind of things, because it is something that is just hosted on the cloud. All that the relay does is bounce off that incoming request to a proxy running somewhere. That proxy running somewhere is the one which is actually connecting to your on-prem system. So basically you have a web proxy running inside your enterprise. That proxy is connecting from behind your firewall to your on-prem system and is providing a REST endpoint that can be accessed only from the relay. So you kind of establish a tunnel between the relay endpoint and your on-prem system, and they are communicating over HTTP. So you are not opening up any additional firewall, you are not opening up any additional network ports or any such thing. So it's a regular HTTP traffic that is going on, and when the external client is hitting the relay, that request is just forwarded back to this proxy. So the technology is not new, it's been around for a long time, just that the implementation is new. This technology used to be called reverse proxy in the past, so it's been around for a long time. But the fact that you don't need an additional proxy server, the fact that you don't need a whole lot of complicated hardware for doing that, that is what is new. Conceptually, it's been there for a long time. Reverse proxy used to cost like multiple thousands of dollars, and you needed to have a very smart network administrator to make that possible. Now those things have been obfuscated, and it's just a matter of a couple of mouse clicks that makes it so easy. So those are the kind of technology that we wanted to cover today. And in case of how it has morphed from BizTalk server to Azure App Service, this is one simple quick slide that shows that BizTalk server has been around there for a long time, almost like 10, 12 years now. Since then, last 2 years back, we introduced BizTalk services, which was an initial version of certain limited set of capabilities on the cloud. Now it's morphed into Azure App Services, which with a full-blown application platform, much beyond integration. So this is how the integration as a platform is evolving across Microsoft. So now let's take a quick look at the implementation of hybrid integration. So there is, if you look at that, I don't know if I have this pointer, the dotted line there is your network boundary for on-prem to cloud and cloud connection or external entities. So on the on-prem side, I have a variety of LOB systems, be it Oracle, SQL, SAP, or homegrown systems, and I need to connect that to applications that are external to me. Applications external doesn't necessarily have to be Azure hosted. It could be anything, but we are using Azure as an endpoint for all external entities to connect to. So these external applications need not connect directly over my firewall. They are connecting to this Azure endpoint, which in turn has a hybrid connector that connects over my firewall. Any questions on this so far? All right. Yes, please.
How do you authenticate and authorize the external systems that are connected to the edge?
Great question. So the question is about how do I authenticate and authorize external applications that connect to my endpoint. So principally all that we are doing here is I have a web application running on Azure where I could do authentication right there at that level. That could also be managed using API management where I can do one more level of authentication. And the connector there, once it goes behind the scene, it is connecting to another web proxy behind the scene where I can have a local authentication if required. Right, so there is authentication at multiple levels, that ability for managing that authentication at multiple levels. But typically all it does is just a web proxy call going back. Right, so this is a website running on Azure. There is a website running on on-prem IIS server, your Internet Information Server. And I can have authentication done at both the levels. Yes, please.
Does interact with Active Directory at all? So you can extend that authentication authorization?
Does it interact with Active Directory at all? Yes. So the Azure also provides another service called Azure Active Directory, which allows you to federate your enterprise Active Directory with Azure Active Directory. There you can do federated authentication, so the Kerberos token passes along. Yes. All right. So let's see a very quick demo of. Sorry. Okay. So the scenario that I have is it's a super simple scenario. So I didn't want to complicate this demo because I wanted you to focus on the technology behind this rather than the scenario. So the scenario is like a mobile developer is asked to create a simple application that connects to an on-prem system. That's all the scenario. So what does it take for him to do this? These are all the challenges that he goes through. So if nothing else, this is the takeaway slide that I want you to walk away today, because this kind of summarizes the capability of the platform in one slide. Accessing an on-prem LOB system. So forget about SQL Server here for a minute. SQL Server is the simplest of LOB systems. But accessing an on-prem LOB system means we need to have authentication mechanisms. We need to have ability to audit who is doing what. And we also need to have connection pooling, which is a pretty complicated technology. So let's say your SQL Server supports only 100 connections at a given time. So as a SQL client, you can be making connections all you want, but SQL Server could be throttling you there. So typically on a middle tier layer, you would do connection pooling. If you look at all of these scenarios that I have outlined here, these are all typically the middle tier that we are used to on a 3-tier architecture. Somebody has to manage authentication, somebody has to do connection pooling, somebody has to do throttling. And then there is a need for traversing across firewalls, traversing across network boundaries. And you also need to be able to manage that web endpoint. So typically if you are doing it today, if you are an iOS developer or a mobile developer, typically the way you would do it is you would create a web proxy and host it somewhere on a web front end and provide this. But because you created that web proxy, you are supposed to manage that. You are supposed to scale that. You need to make sure that it is highly available. You need to make sure that it is scalable on demand. All of those things is the iOS developer who has got nothing to do with his web proxy, he's supposed to manage all of those things now. So that's a pretty complicated scenario because that is an external entity which is external to your application, but it is critical for your application to run, right? How do you as a mobile developer manage that? And you are also expected to know about your LOB specific lingua franca. Like let's say if I'm talking to SQL, I need to know T-SQL. If I'm talking to Oracle, I need to know PLSQL. If I'm talking to SAP, I need to know about BAPI and RFCs. I'm a poor iOS developer. I don't know any of those things. How do I communicate with these back-end systems and still provide my simple front end? Right, so this is the typical problem scenarios that this platform is aiming to achieve. Right, so the demo itself may be a very dumbed down scenario. You could say like it's like our typical BizTalk servers in a demo, right? Read from a file and write to another file. So The demo itself might look like very dumbed down, but the concepts that we are trying to talk here is at a very application platform level, right? So let's look at that simple demo and see what does it take to do that simple accessing SQL Server hosted on-prem. I need to connect to 5, 8.
This changed.
Thank you. Shows up
Looks
now?
good.
Okay. So this is the new Azure portal for those of you who are new to this. Under web and mobile, if you look at this, I have web app, mobile app, logic app, API apps, and so on and so forth. One other point that I want to touch base here, I'm not sure if Mark touched that there. The first slide that where I picked up was there was API apps at the very foundational level. Then there was logic apps, there was mobile apps and web apps. So API apps was spreading across all three of them. So the reason why I want to go back to that slide is to emphasize the fact that everything that we are talking about is in the context of an API app. So what is an API app? It is kind of new and kind of old technology in a new bottle, you could say, for most of you. It is a web representation of your logic. Your logic could be, it's not necessarily a connector. Most of the people, at least initially, think that an API app is a connector. A connector is an API app, but not all API apps are connectors. So let's parse that for a while. I might have a simple connector which does loan calculation. It has got nothing to do with a connector. I pass certain parameters and it is returning me certain computation. I might have a connector, I can demonstrate a connector today, which API app today, which is a regex validator, just a regular expression validator. It's got nothing to do with a connector. So what is a API app? It is just a REST endpoint which implements a web API behind the scene. So anything that you can put in a web API. So if it could be represented as a web service, it could be an address validator, it could be your regex validator, it could be your loan calculator, it could be your string manipulator, anything. A connector also happens to be an API app, right? Because it has a simple logic which says, how am I going to connect to Salesforce? How am I going to connect to SAP? How am I going to connect to SQL? Right? So that connection logic is implemented within that. So the API app by itself is just a small piece of code, a modular piece of code that does one thing and one thing only. That one thing could be provide connectivity to SQL, provide connectivity to HTTP, provide connectivity to SAP, or manage connectivity with SAP, or do this regex calculation. It is doing one thing and one thing only. Why is that important? That it's a very foundational understanding where we say, as a developer, I focus on doing that one thing. How this regex calculator is used by somebody else, I don't care. That is, the person who is using is, he has to figure out how he's going to use it. All I'm doing is like, give me a string, give me a regex, I'm going to validate this against this string. That's all the regex calculator's job. In this case, for this purpose of this example, we are going to be using two API apps. One is the mobile application is going to post me a HTTP request and getting back a HTTP response. Obviously, I need a connector for HTTP. And that HTTP request, once it comes in, needs to be sent over to SQL, and I get a response back from SQL. So I need a SQL connector, right? So these are the only two connectors I need. I'm taking a HTTP request, so I need a HTTP connector. I'm sending a SQL request to SQL, so I need a SQL connector. These are the two connectors I'm going to be using. And build a client application. The client application is just going to make a HTTP request and get a response and display it. That's all it is going to do. A simple HTTP request response, and behind the scene it is that goes into SQL and comes back. Right? So now let's make sure that we understand API apps clearly, because at fundamentally it's a simple web API decorated with specific attributes so that it can be managed as an API. That's pretty much what it does. So why are we making a big deal out of this here? As a platform, as I said, App Services is providing you a web platform to host these API apps. If you look at the problem statements that we listed earlier, we said you need to have a scalable platform, you need to have a managed platform, you need to have somebody who already implements authentication and authorization, who already provides you a diagnostic scale. All of these things are provided by the platform. Platform in this case is App Services. So for that platform to interact, it is not just over a web API, it is interacting through it as an API app. That's all it is. If it was your own web API, you would be implementing it on your own web server and manage it all by yourself. But for App Services as a platform to manage it, you implement it with specific interfaces, which is called API apps. Is that clear? For all practical purposes, from a technology perspective, it is a regular web API, nothing different about it. So let's get back to this demo. And I'm going to show you a very simple scenario of how it is implemented. If you go into Marketplace, you will see a whole lot of existing API apps that Microsoft has already released. These are all existing API apps that Microsoft has released. So if you look at these, there are like a bunch of connectors, right? So these are all these connectors that most of you are familiar from the BizTalk world, right? These used to be called adapters in the BizTalk world. But now you have a whole range of it, which much beyond what we had with BizTalk. Especially for the SaaS side of it, which is where BizTalk was severely lacking, like connecting to Twitter, connecting to social media services and those kind of things. So now let's go back and look at one of the things that we have implemented for this particular one. So here I have an API app called as SQL Demo. This API app is allowing me to provide a hybrid connection to an on-prem SQL server. So this is exactly similar to what we had with hybrid connections in BizTalk services. If you click on the API definition for that, it says what are all the operations that you can do on this particular SQL server. Right? It says you have you can do all the CRUD operations, both as XML as well as an JSON. How did it get it? So if I click on this hybrid connection, in this particular case it's already connected, but let's just take a quick look at the UI. The only input that I need to provide is my service bus connection string. So I provide namespace in service bus, and based on that namespace, it creates the corresponding relay on my service bus endpoint. Here on my service bus endpoint, it actually creates those relay. And says if there is a listener listening on that endpoint. Right, instead of me manually creating and plugging it all together, so you have a simple package which by just downloading and clicking that package, it has connected me to my SQL server and created a proxy on SQL server. So let me connect to that SQL box, which is just a virtual machine running. On that virtual machine, if I open up my IIS Manager, it has created a website called as Microsoft SQL Connector. And within that, it has provided in that web config, this is how we configure that. Like if you have to manually configure it on any other website. Okay, it doesn't allow me to show it here. Okay. So if I were to open that web config, it will put that relay endpoint there. So all that this website is doing is bouncing off of the service bus relay. So now,
and so this application now running in Azure Cloud is connecting then to the database that you're running in the VM on your machine.
Correct.
Okay.
So here I have a simple Android app. So let me go back to, I have it on my Android device, but I thought it's a lot more easier to just show it from the screen here. So all that this Android app is taking is where should I post this request. So this is the endpoint of my API app running on the cloud. So if I look at my API app running on the cloud here, this guy has this address here. I can post directly to this SQL server, but this SQL server is not expecting a HTTP post. Right? The SQL server is not expecting a HTTP post. So the way that I'm going to stitch these together is through a logic application, which is basically a glue that brings the two together. Let me show you that logic application. So this logic app is a browser-based interface where you can just drag and drop things. Very similar to Xlang orchestration principally in BizTalk server, but don't compare it with Xlang because it's a very different implementation. So the use case here is I can use this logic app to explain a very simple process. It could be data flow, it could be process flow, it could be business flow. In this case, I am just defining a data flow. I'm receiving a request from HTTP, passing it on to SQL connector, getting the response back from SQL and sending it over to HTTP. This might sound kind of funny to many of you. HTTP is a request response protocol. Why do I need to have a request separately and a response separately? Right? Any idea why do I have it as two different shapes here? It is stateless. So I have to explicitly specify what is the request ID to which I am mapping it back. If you look at that third card that I have with HTTP listener, I am explicitly specifying the request ID to which I want it to be matched. Right? So I get the initial request from the very first card, and in the second card, I am specifying that, okay, use this SQL connector that I have created. That SQL connector already knows how to connect to my SQL server, and it knows that there is a table called, database called Northwind with a table called orders in that. And I want you to run that select statement, select star from that, and there is a where condition. I want you to run that where class. Whatever that you get back from that, return it to the next shape, the HTTP listener shape. All right? So now I'm using two different connectors, and now because I'm getting a HTTP input as my first shape, that means I can post a HTTP request to this guy. Right? So now let's go back to that API app for that HTTP request, because behind the scene that's also an API app. So in this HTTP listener, we'll have address where I can post that request. So this is the host address where I can post to. This is the same address that I'm specifying here in my client app. Right? So the client app says, okay, where do you want me to post? So I'm posting it here, and I can give some conditions here and say, go search, fetch that. So it is making a simple post. And once that post comes, there is a workflow that runs behind the scene. The workflow in this case is get the request, pass it on to SQL connector, get the response back from SQL connector, return it back to HTTP listener as a send request, as a send response. This is the response you are getting. Right? So the goal is not to highlight the demo here. The demo, intentionally I have kept it like really dumbed down demo. Right? So I don't want you to focus more on what the application is doing or anything. The application is not doing anything. It is just doing a request response. I could have shown this to you with simple Postman or an IE demo. Right? But intentionally I wanted to show it to you in an Android application because the scenario is every mobile developer will be going through this scenario. Right? You have to make a request to existing data source and to get that response. How simple is it now to manage the data source? Right? Whether it is a hybrid application connecting to a SaaS service, I could replace that same SQL connector and put Twitter in place. I could put Salesforce in there. I could put SAP in there. I could put whatever I want without touching my mobile application. Right? Because all that the mobile application is doing is just a request and a response. It doesn't really care what that response is. Doesn't really care what the request is. Right? So I can change my logic within the workflow instead of telling that, okay, I had some logic here. The logic I had in my workflow was like where city equals something, right? I had it as city equals Seattle and employee ID equals something. I could change that condition there and not have to worry about anything on the client side change. That means these are all data flow changes or business process changes that can be implemented independent of the data source or independent of the client app. So I'm just managing it at the middle tier layer.
Here I see that as ship city is Seattle and employee ID is 4.
Yeah, so I can change this condition here and have a completely different set of results on my client and not have to change anything on my client side. Yes, please. Yes, yes, yes.
The question again.
So the question was, can I do conditional flows here? So the flow language itself is a very simple language. Even in BizTalk server, we had the language, the Xlang language was relatively very simple, but people thought it was complicated. So here we have tried to make it even more simpler. So you can add a conditional change where if the result that I returned there was employee ID equals XYZ, do something about it. The do something about it could be take a different route or go through a loop, right? So I can have a request over a receive over a list. So basically whatever the return thing that you are returning in this case, body is an array. I can iterate over that array and return one element out of it, right? So these are very simple implementations of a pretty complicated algorithm behind the scene. There are about 8 different patterns of workflow which BizTalk server had supported. Like let's say there was multiple scopes. You could have atomic scope, you would have larger scope, you would have loops, inner loops and those kind of stuff. All of those things are not there here, but some of those things we will be bringing back to this one. Right? For now what you have is parallel flows, sequential flows, loops, and conditional loops. Right? So within loops you could have do while, you have do until, you have for each and all those kind of stuff. So what I have here is do while. Right? And for implementing anything, like let's say, because these are all just simple card-based implementation, there may be restrictions in the UI. But if you click on the code view, this shows the JSON representation of that execution. So I can use any JSON editor and actually modify this whole thing. Right? So there is nothing complicated about it. If you were to look at that implementation itself, so every card that we had there, it's a trigger and it says there is the authentication for that particular one, and then there is I'm making a HTTP request and then I'm making a SQL call, and these are the parameters that I'm passing it at every level. Right? So the implementation of this within JSON itself is very simple. So the goal here, if you look at it, I can take this JSON, for all practical purposes I can copy this JSON and put it on a web role on any web server. As long as that web server has access to my API apps, this JSON can execute. Right? There is really nothing special about, there is nothing platform binding into this. All that I'm specifying is, hey, there is one API app called as HTTP listener, there is another API app called SQL connector. Take this request from HTTP listener, pass it on to SQL, get the response from SQL, pass it on to the HTTP guy. That's all it is telling. I can take this JSON and put it on any web server and it will behave exactly the same way. Right, so now we have kind of separated out that logic of runtime versus design time. So I'm not putting any restrictions saying that hey, you need to run it only on this platform or that platform. There is nothing .NET about this. There is nothing Windows about this. There's nothing SQL about it either. It's standard JSON, you can take it to any web server and run it. So why is this important for integration applications? Any thoughts? Yeah. So if you were to think about it from a BizTalk server background, if you notice, I never specified a schema anywhere. Right? If I had to do the same application in BizTalk server, the first thing I had to do was I had to connect to SQL and get my schemas as XML schemas, and then map that XML schema into my HTTP request response. In this case, I never specified a schema. Because it was a JSON request response, the metadata was already part of it, which it was able to map throughout its flow. Right? So that's a big change from where, how we were doing it in the past to how this is done. So everything that is represented, that is flowing through the system, is represented as a JSON data set. So at the end of each card that we saw there, I received HTTP. There was a point of persistence. That means the next guy need not be SQL. It could be SAP. It could be Oracle, anybody. All that guy needs to know is that there was a request coming in. Same way at the end of the second card, which was SQL in this case, the response was a body array, which was a JSON object. Right? It was not a SQL record set. It was a JSON object. So the third card, which picked up from there, just had to read a JSON object and continue from there. Right? So there was really no need for data type normalization inside a workflow. So where did this data type normalization happen? Because SQL obviously returned a record set, a SQL record set. Somebody had to convert it into JSON. So the API app, which we created in the past, at the beginning, it returned me a JSON object, right? Instead of returning me a SQL record object. So that part is very important as integration developers for us to understand that now I can connect to any data source. Yes, please.
Yes, can you please the technology for low latency apps?
The low latency app in this case is, let's say, read from Twitter kind of a thing, or read from data ticker, or stock ticker. So is that the kind of scenario, or coming back to on-prem and going back?
I'll go to the on-prem back.
Yeah. Yeah. So the latency that is being added here is about, at least as of this release, it's about anywhere between 300 to 500 milliseconds for the workflow to get started. Right? So the workflow is not a continuously running one. It is, I have a HTTP listener. It's not a continuously running one. Only when you get a HTTP request, I'm going to kick off the workflow in this particular scenario. Right? So the time lag that I have between the HTTP request coming in and the workflow kicking off may be up to 300 milliseconds. But once the workflow is running, it is continuously running. Right? So, like I post the first request, second request, third request, second, third, and fourth just keeps going fine. So you will have that one. And then the second part is about, like let's say if I'm connecting from SQL connector to on-prem system, there again there's a layer of latency added because there is going to service bus relay, bouncing off to local server, and then converting it from SQL to HTTP back and forth. That cost is also there. But I don't see that significantly high once you establish that relay. The first call once again will be delayed because I'm establishing the relay connection. But once the relay connection is established, it goes pretty fast.
Is it one for every phone, or is it one for every person that's connecting?
No. Independent of, so the client in this case, right? So let's say client 1 through client 100. So the first client connects and makes the hit to my endpoint. Like let's say that HTTP listener endpoint. That endpoint wakes up and starts the workflow, which in turn connects to service bus relay, which in turn connects to SQL. All of those things are now established. Every other client is also still hitting the same HTTP listener endpoint. Right? So from there on, it doesn't matter how many clients are connecting. So you can scale that web application also and say, hey, okay, keep this always alive, just like we do with any other website. We can keep it alive so it doesn't go to sleep. If you think that we need to be really responsive, you can keep that alive and keep that heartbeat going. What are we doing on time? Okay. So now let's look at another very simple example. So this example was like we posted from a HTTP client, which was relatively simple. But think about another scenario where most of our assets today inside the enterprise are file-based. Once again, the scenario is, forget about the scenario, it's a very super simple scenario where I'm just reading from a file and writing to a file. But while reading from a file, I get the same where condition that I had there in my HTTP post. I'm giving that where condition in a file. So where ship city equals Seattle, that's the where condition. If the ship city equals Seattle, then return me its zip code or something. So that's all the flow is. But the concept that we are trying to prove is how do I connect to an on-prem resource, which happens to be a file system in this case. So just like I could connect to a SQL server, I could also connect to a file system. The hybrid connector is exactly the same. I'll have a proxy just like I'm connecting to a SQL server. Now the proxy is connecting to a local file server. So this one is slightly, I'm reading from a file connector every n number of minutes. Whatever the file system is telling the string, I'm passing it on to SQL, getting that response and writing into another file connector. So let's look at that. So this is the file that I'm reading, where I say ship country equals USA. If ship country equals USA, go get the data, and for the whatever the output of the first record is, return me the what do you call? Let me see what I'm returning. So I'm returning the zip code, right? So it is just returning one value. So and I'm going to be reading this SQL in file continuously. So like let's say instead of USA, let's say it's France. So the last update was on 12/25, that had 87,110. So if I can just give it another about a minute, that recurrence is going to happen and it is going to read this file again and write that output once again. So the goal of this demo is to show that I'm using that same hybrid technology, the one that I was using to SQL connector, to connect to a file system. Once again, behind the scene, all I have is a web proxy running on that web server. If I go to that web server here, I have a file connector. Just like I had SQL connector, I have a file connector. That means I can connect to any on-prem resource using that same technology, and it doesn't matter whether it's reading from a file, reading one string, or reading an entire text, or reading an entire record set, it doesn't matter. The connectivity is established in the same consistent manner. That means as a web administrator, now I can manage all of my LOB systems in a consistent way. Be it SAP, be it Oracle, be it SQL, be it file system, be it MQ server, be it any other homegrown LOB systems, or SOAP endpoints, or REST endpoints, or web endpoints. Any on-prem system, it is managed and connected to in a consistent way. So now if I go back to, like, let's say 12/27, this guy was updated, so I have a different value here. So that intentionally I'm keeping these demos like very lightweight, like so you don't have to focus on what this demo is doing. The demo is like very simple.
But I think what you're showing there is the relationship between the API apps and the logic
apps. Yep. So in the previous example, I used two HTTP connectors. In this example, I'm using a file connector. And to answer to that gentleman's question about latency scenarios, instead of waiting for that request to come in, I'm doing it on a consistent timely basis. So there is a recurrent schedule. It says, okay, do every X number of minutes or X number of seconds. So it's continuously reading that file, right? So it's not waiting for that file to be updated. So this is a different pattern. So let me also show you another simple scenario where these were all things that Microsoft had implemented, right? Like apart from the hybrid connectivity part, the power of the platform comes from partners come and extend this. So it's not about just Microsoft's ability to provide these connectors or provide these simple API apps and those kind of stuff. So the platform itself is based on standard web technologies. So if you can create a web API, you can create a logic app, or you can create an API app. If you can create a collection of API apps, you can create logic apps. And the data that we are showing here for purpose of monitoring, diagnostics, tracking, it is all publicly accessible. There is nothing hidden that only Microsoft has access or any of those things. So these were all things that we learned from feedback from BizTalk server days, where people said, hey, I need to be able to create my own pipeline components. I need to be able to create my own data view of tracking. How do I do tracking database extensibilities? So these are kind of things that people have been telling for past 5-10 years based on multiple use case scenarios. So what we ended up doing here is like instead of recreating all of these views specific to an industry or specific to a use case, we said, hey, we will provide you this data at every point that you need. be it at an API app level or at a logic app level or at monitoring, diagnostics. Because it is a website, you have access to it through standard web interfaces. So some of the partners, they went and created some sample scenarios. I wouldn't call them as products because the our product itself is in preview. So they ended up creating some sample scenarios to see how does this tracking work, how does monitoring work, how does diagnostics work, what does it take for me to create API app that can be published, right? That can be used by all other customers. So one of such scenario that I wanted to focus today was simple application called regex, regular expression. I like this demo because one thing is it's super simple. There is nothing special or complicated about this. So it runs on a regular recurrence. It takes string as an input and implements a regular expression. And the beauty is, like, I have used two different regular expressions on the same string. And I am sending out a mail. So the SMTP connector was already there. So we are mixing and matching custom API app along with Microsoft API apps. So the recurrence API app and the SMTP connector API app are two things that are out of the box from the platform. The regex API app is something that is created by the partner, right? So we are not differentiating between the two. In the logic flow, they all see the same. And the parameters look consistent, and the return types also look consistent, right? So we don't have to worry about what that regex does. We all have different experience with regular expressions. So in this particular case, I am passing one string which contains the last part of the string contains the email address, and the one part of the string contains a body. One part of the string contains some subject line. I'm just passing them all into an SMTP connector, and the regular expression validates that string into multiple pieces, and based on that, I'm going to return this. So like, let's say, let me just validate that. If we go to this, Control A this, see this, and I'm using a regular regex validator just to see that we are not faking things here. Let's evaluate this. So this is the regular expression and this is the string. Based on this string, it says there is one match which says ignite your system integration with logic apps. That's the part of the string that I'm validating. And another part of the string is this regular expression. This regex is going to return me my email address, right? So I have two regular expressions. So the first regular expression is going to return the email address. The second regular expression is going to return the subject line. And I'm going to click on to the send SMTP. The first one, that 2 goes to my email address, and the subject line comes from here, and this is the body. And if I run this, it is just going to send an email with that content, right? So the point that we are trying to make once again here is not about the demo itself. It's more about what does it take to build that, right? So almost every one of us are familiar with creating a simple .NET application that does regex validation. There's nothing fancy about it. But now I can take that simple logic and make it available as a API app and can be used by anybody in any scenario, right? In this particular scenario, I had a constant string which I was using to send an email. Imagine that I had to use that same thing in the context of my SQL Server demo. I could take that same regex connector, put it as the output of my SQL, and do some validation on that, and then make the next decision, right? So now that logic that I had for validating regex can be used in any scenario. So I don't have to worry about how to pass parameters to it or how do I get the response. It's all in a very consistent way every single time, right? So that was another scenario. And the third one that I had from that same partner, so the partner's name in this case is Intsoft. They are based out of Sweden. They were validating this while as part of learning app services. They were trying to figure out, hey, how do I log everything that is coming in? So the first approach that, as everybody else, was they say, I need to store everything in some database. Then they subsequently figure out, I don't have to store it, it's already stored on that user subscription. As to every action that you are doing on every API app is already stored. So it is called diagnostic log store that Azure provides for all subscriptions. So there is nothing special about it. So you just need to connect to that and say, hey, these are all these various applications that is running in my particular subscription. Can you show me what happened in my given application? So in this case, the regex demo is my application. If I click on that, it says, okay, show me all the activities that were done on this particular app, the past 10 days, past 15 days, past 1 hour. So it loads, this loading is actually coming from the Azure database itself, data store, not database. So all that they have created is more like a queryable form. And in this query form, they just made it a little bit more friendly and say, hey, you can have your own correlation token and you can group by and those kind of things. And say for this day, show me everything. It shows all the activities that happen, and because it is coming from the Azure store, you can actually view that message, you can save that message, things that you could do with tracking service in BizTalk server, right? So the Uber point here is this is an application platform for developers to try out. So don't think of it like an end product like BizTalk server, which was defined to do feature A, feature B, feature C. This is an application platform for all developers to try. So the application platform provides you a scalable host. It provides you an authentication engine which is already coming from Azure. So we are not reinventing the wheel there. And it is based on known technologies like based on standard web technologies. So there is nothing new that you need to learn. You could use any web languages of your choice. It could be Node.js, it could be .NET, it could be Java, it could be ASP.NET. You can bring any known web technology of your choice. And for most of the common web development or mobile development scenarios, so we are not differentiating between web application and a mobile application for purpose of this platform discussion. So it's all the same application platform. And we are bringing in all of the integration scenarios that were hitherto considered niche for only integration scenarios. All of those integration patterns are applicable across all application development scenarios. So it could be something as simple as connectivity. It could be transform. It could be validation. It could be authentication and authorization. It could be tracing and tracking. All of those things. Like let's say in this particular case, this regex demo that we showed. As an ASP.NET developer, you would be thinking like, why am I doing tracking and tracing on this? Right? But as an integration developer, that's a very common scenario. Right? For any integration application, the first thing that you would ask is like, hey, what is my tracking story? What is my tracing story? What is my diagnostic story? You wouldn't think about those things in the context of an ASP.NET application. So now, bring that same infrastructure that you would do for integration also for these mobile developers. So now I can not only use it for diagnostic purposes, but I can also build enterprise class applications using that platform, right? So this is more of an introduction to an application platform rather than just a pattern. So hybrid connectivity was just one of the patterns. So we have a deep dive on this on 2 different sessions. There is a deep dive on app services by Mohit Srivastava on Thursday. And there is another deep dive on logic apps and workflow design, workflow engine design by Stephen Siciliano, one of my co-workers in the team. So please do join those 2 sessions because they'll be talking about the internals of how API apps are hosted and API app scales. And we'll also be talking about the internals of the workflow engine.
In the minutes we have left, I thought I'd just do a quick summary of some of the capabilities that we have related. So what Guru was able to demonstrate was the interaction between API apps and logic apps. So on March 23rd, we actually announced the public preview of App Service. And on March 23rd, out of the gate, we offered a set of built-in API connectors, protocols, and services that really deliver on the vision and the promise that we had proposed related to app service and delivering the next version capabilities. There's a lot of opportunities that partners and customers are helping us with now in developing, and some of these services and applications are being made within their own private environments for their organizations to leverage, and others, partners, are actually building capabilities that will be made available via the marketplace for broader ecosystem consumption. And in terms of completeness of vision, we are in preview right now, but you can see it's a significant enhancement in what we're delivering in preview versus what we had available in BizTalk Services version 1.0. So significant enhancement in platform capabilities as we've moved into App Service Preview, enabling not only a more democratized integration platform that exposes these powerful capabilities to web and mobile developers, but also giving pure play integration developers the capabilities they need, both on private cloud as well as public cloud platform. So very significant enhancement of capabilities and a lot of excitement around these capabilities.
Yeah, the things that you see on yellow simply means that it's work in progress. Say, for instance, that marketplace and out-of-box connectors, we call it as work in progress because out-of-box connectors is something that keeps on evolving over a period of time. But marketplace is an important distinction. Say, for instance, the first screen that I showed you about clicking on Browse Marketplace and it shows you a set of connectors. Similarly, you may want to, like that regex connector that we had, that was something that was not out of box, but a partner had created. Imagine that you want to create it exclusively for use by your enterprise only. You want to create an API app, like let's say a loan calculator or a claim processing application that is specific to your industry and you want to host it in your enterprise only. That's an enterprise marketplace. So those are kind of initiatives that are cross-spanning across Azure. It is not specific to integration alone. It is applicable to all workloads. So we will have an enterprise marketplace which will have those API apps and those logic apps that are pertaining to your enterprise that you can host and manage. And there is also, once the private cloud is in place, all of these functionalities will also be available on the private cloud. So it's not necessarily Azure public cloud only. If you look at it, the technology behind the scene are all simple web server based, JSON based technologies. So there is nothing preventing you from a technical side of it on hosting it on inside your enterprise. So just to recap, the hybrid connectivity is just one of the patterns of this application platform. So this is not the only scenario. That's just yet another scenario. And every connector is an API app. Not all API apps are connectors. So with that, if we have any questions, we can take that now. Thank you all.
So as we're getting ready to wrap up, please don't forget to fill out your evaluations. I thought I'd show you just one of the training videos that we have available online. There's a whole suite of training and information that's available. This is just one.
Here's a dream. What if you could quickly and easily build modern business apps for any device? Apps that use data from any source. Apps that integrate with your enterprise systems and processes without scaling worries and without having to learn new tools or deal with back-end infrastructure. Well, you can. Microsoft Azure App Service is the one-of-a-kind cloud service that unifies everything you need to quickly and easily create apps for any platform or any device. Create and deploy web apps that scale with your business. Build and consume APIs across your data center and SaaS applications using pre-built connectors. Build apps that reach customers anywhere, anytime, on any device. Use tools you already know and write less code than you've ever had to write before. automate business processes in just a few clicks, with pre-built API connectors and business process templates from a vibrant ecosystem. Plus all of the enterprise-grade security, geo-distribution, and high availability you expect from Microsoft Azure. Azure App Service. Create powerful web and mobile apps faster than ever.
Thank you for joining us today. We'll look forward to seeing you through the rest of the week. We're headed straight to the expo right after this session. Look forward to answering any further questions that you have. Thanks again, and enjoy your week at Ignite. Thank you.